Greetings. In this video, we will be looking at table structures or table schema. At the end of this video, you should be able to accurately draw a table structure or a table schema. If you are new to this channel, you should subscribe so you do not miss any new videos. Also, if this video was beneficial, please like and share. Thanks. So, without further delay, let us begin. Now, if you're new to database management and is unaware of key database concepts and terms, then before you proceed with this video, please go and watch my other video titled Introduction to Database Management high school level. Alright, so by now you should know that a table structure is a plan that shows the name, data type, and field size of fields in a table. So let me repeat. A table structure is a plan that shows the name, data type, and field size of fields in a table. So basically, one would draw the table structure or table schema before creating the actual table, right? Before I show you how to draw a table schema or table structure, I want to quickly highlight two very important terms which were discussed in the video titled The Introduction to Database Management high school level, and these terms are primary key and data type, right? I want you to remember that a primary key is a field that acts as a unique identifier for each record in a table, right? A large number of the tables that you will eventually create will have a primary key, right? In this video, I will show you one key importance of having a primary key. However, for additional information on primary key and data types, please see the video Introduction to Database Management high school level, right? Now, the next important term is a data type or field type, right? And a data type or field type basically determines the type of data that a field can store, right? When a table is designed, all the fields are set to accept a particular type of data. Just remember that. Again, if you're absolutely new to database management, please go and see the video titled Introduction to Database Management high school level. Alright. Now, the four main types of data, or the four main data types, are what we call alphanumeric. So we have alphanumeric, we have numeric, and there is date, and there is logical slash boolean. So these are the four main types of data type, right? Now, alphanumeric, otherwise called text fields, will accept both numbers and text value. Just remember that. While fields that are of the data type numeric will be used to store numbers, right? And fields that are of the data type date will be used to store days, months, and years. So in essence, it's used to store the date, right? And fields that are of the logical or boolean data type will only let you enter one of two possible values. So those values can be either yes or no, and this may be represented as either yes slash no or true slash false, or for instance in Microsoft Access it might be a little checkbox with a stick or no stick inside of it. Just remember. Alright, so Microsoft Access is a example of a database management system, and it is one of the more popular database management system, given that most persons have Microsoft Office on their computer. Alright, now you should remember that even though we have the four main data type, which are alphanumeric, numeric, date, and logical slash boolean, in different database management system they might have subcategories of these data type. So for instance, in Microsoft Access they have two main type of alphanumeric data type. So in Microsoft Access you have the text data type and the memo data type, which are both types of alphanumeric data type. You'd use the memo data type on a field when that field is going to store a large amount of data, such as a paragraph or a sentence or a large phrase, right? But generally speaking, most time the text data type is used in table structures and in actual database tables, right? Alright, so the numeric data type in Microsoft Access, there are some subcategories such as currency, number, and auto number, and the name are basically self-explanatory. So you'd use a currency when you're dealing with money value, and you will use the number data type when you're dealing with integers and decimal numbers, right? And the auto number is a special type of data type. What it basically does is automatically increment a number when each record is entered, but we'll look at it in more details when we go into Microsoft Access. And in Microsoft Access, the data type, Microsoft basically calls it date/time. And finally, the logical/boolean data type in Microsoft Access, it is called the yes/no. So just remember that, right? So now that you have a general understanding of a table structure, and you have a general understanding of the different data types, right, and the different subcategories that you can use, let us now look at some actual examples. Alright, let us look at some example. And the first example wants us to create a table structure or table schema for a student table called student, which will store a student's name, age, gender, and date of birth. No student will have a last name with more than 60 characters, right? So one of the first thing that I can identify from this scenario or question is that the name of the table is called student. So in essence, we're creating a table structure for the student table, right? Now the second thing that I can identify is that this table will have at least 4 fields, right? It will have one field for date of birth, it will have another field for gender, it will have another field for age, and it will have a field for name, right? However, I am going to break the name field into 2 separate fields, first name and last name, right? You could use one field and store both the first name and last name in it, or you could split the name field into 2, one field called first name, one field called last name, and store the first name and the last name in separate fields. So alright, once you know the number of fields that your table will require, what you will do next is basically draw a table, and your table will have a minimum of 4 columns. So 1, 2, 3, 4 columns, right? Then what you will do is name each column. So the first column you will call field name, the second one you will call data type, the third one you will call field size, and the last column you will call description, right? Then you will decide on the number of rows that you will need in your table, right? Now given that you're going to have 1, 2, 3, and I say I'm going to split up the name field into 2 separate fields, so it's 4, 5, so we need a minimum of 5 rows in this table, right? 1, 2, 3, 4, 5, so a minimum of 5 rows, right? Good. So what we're going to do next is put each field name under the field name column, right? And we're going to find appropriate data types for each field, and appropriate field size and appropriate description for each field. So let's begin. So the first field that we're going to look at is first name, right? And let me tell you something, you can actually name your field names however you want, right? Just try to name them as short as possible and as descriptive as possible. So like for instance, this first name field, right? This first name field, I could call it first name, or I could call it first underscore name, or I could call it F name, or I could call it F space name. You understand, you have options. However, I'm going to stick with first name, and I join both words together. I didn't have to do that, right? Now the data type for first name will be alphanumeric, right, or text, right? So I'm going to use the data type text, or you could use the data type alphanumeric if you want, but I'm going to stick with text, right? Now we will have to make a decision. What is the largest first name that will be entered into this table that we will eventually create? I don't think that there is anybody with a first name larger than 70 characters. So I'm going to say, okay, then my first name field. So my first name field is of type text, and I don't think anybody will have a first name with a value greater than 70, right? Then I'm going to just give a little description. I'm going to say, okay, this this field will store students first name, right? Good. So let's move on. Then we're going to have another field called last name, and I write it different from the first name just to show you that you have options in terms of how you name your fields, right? Now the data type for last name will more likely again be text, not true, text, right? Again, and if you look at the scenario up here, it says that no student will have a last name with more than 60 characters. Cool. So it means that my field size for last name, I am going to stick with 60 characters based on what was given in the question or scenario. And for the description, I'm just going to give you a brief little description. This field will store students last name, or I could say students surname, right? Cool. So the next field that should be in this table structure is age. So what I'm going to do under field name, I'm going to put age, and data type for the age field will be either numeric, or you can stick with the word number, whichever one, right? And your age is going to be an integer, not a decimal, not true. So under field size, we're going to type integer. If your age could be decimal like 10.5 or 8.6 here, then you would put decimal. But because your age can only be a whole number, you're either 1 or 10 or 15, etc., then we're going to use integer, right? And for the description, I'm just going to type a brief description. Stores age of student. All right, the next field is gender, right? And gender will be either male or female, not true. Now, so the data type for gender would be text or alphanumeric, but I'm going to stick with text, not true. Now, what would be an appropriate field size for gender? Think about it. If I say that the gender field will only store one of two values, male or female, so female or male, what is the largest possible value that can be entered into the gender field? Then it would be female, not true? Yeah, and female would have how many characters? It would have 1, 2, 3, 4, 5, 6. 6 possible characters, not true? So it means that the value that will be entered into the gender field will probably not pass 6 characters. But what I'm going to do, I'm going to just add an extra 2 to it just to be safe. So I'm going to say, okay, the field size for gender, right, is 8, just to be safe. Let me delete this. Then I'm just going to give a brief little description. Stores gender of student either male or female, right? All right, the next field will be date of birth. Now you have option here. You can either call it date of birth, right? Or as I've said before, you could call it dbirth, or you could call it DOB, or whatever. However, I'm going to call it date of birth because it is more descriptive. Once I look at the title date of birth, right off the bat I am able to recognize that whatever value is stored in this field is more likely the date of birth, right? Cool. Now the date of birth field, what do you think is a very good data type for that? Date, not true? Cool. So the date data type will be used for the date of birth, and when you use the date data type, you leave the field size blank. You can just put a dash there if you want, or you just leave it blank. And for the description for the date of birth, I'm going to leave it blank just to show you that you can actually leave some field description blank if needs be. However, in the real world, you want to have as many description as possible, right? Cool. So here is an example table structure for the scenario that was given here. Let's dissect it a little bit. So if you look here, guys, we have how many columns? We have 1, 2, 2, 3, 4 columns, right? And we have how many fields in this table structure? We have 1, 2, 3, 4, 5 fields. Not true? Alright, cool. So this is the table structure for the scenario that was given in example 1. Alright, so let me show you an example of how the table created from this table structure would look. Right, so this is a table structure, and this is an example table created from this table structure. Right, so in the table structure, right, these are the fields: first name, last name, age, gender, and date of birth. And if you look in the actual table that is created from this table structure, you realize that the fields are now the heading of this table. So here we have the first name field, and here it is the heading for this column. Here we have the last name field, and here it's actually the heading for this column. We have the age field right here, and here it is the heading for this column. We have the gender, same thing here, and we have the date of birth, and same thing here. Right, so this is an example of how the actual table would look for the table structure student. Right, cool. Now this table structure, right, is perfectly correct, right, for this scenario that was given above. However, there is something that I want to show you, right, and that is how do you identify a primary key. And if you remember, a primary key uniquely identify a record in a table. Not true? Now let me use this table as an example. So I'm going to use the student table as an example to show you the importance of primary key. Right, alright, so in this table, how many rows do we have? We have 1, 2, 3, 4, 5 rows. So in essence, in the student table we have 5 rows, which is all of this here, or 5 records. We do not count the heading as a part of the number of rows in this table. Right, so again we have 1 record, 2 record, 3 records, 4 records, 5 records. Right, and how many columns or fields do we have in this table? We have 1, 2, 3, 4, 5 columns or fields. Right, now look at this. We have 1, 2, 3 John Brown. Right, so we have 1 John Brown here, we have another John Brown here, and we have another John Brown here. Now if I ask you which field in this student table could be used to uniquely identify each student in this table, which field would you tell me? You couldn't say age, because you realize that age can have repeating values. Look at this, for example, you have 14 here and you have 14 up here, and the definition for a primary key is that it uniquely identify each record or row in a table. Not true? So we couldn't use the age field as a primary key. Why? Because the age column or the age field will have repeating data, such as the 12 in this. You can see where the 12 repeat, and you can see where the 14 repeat. Not true? We also couldn't say the gender field. Not true, because the gender will actually have repeating data, the male and the female. Not true, so we couldn't say that. We also couldn't say the date of birth, and unless in our table no 2 persons will have the same date of birth. However, in real life, in real world situation, 2 or more persons will actually have the same date of birth. Right, so right off the bat then, if you look here, you have this person is born May 12, 2007, and this one is born May 12, 2007 as well. So right off the bat we know that we could not use the date of birth field as a primary key either. Right, so that is out of it. Could we use the last name field as a primary key? Again, no, we could not. And why we could not use a last name field as a primary key? We could not use a last name field as a primary key because you might have more than one student in this table with the same last name, which is proven by Brown here. So we have Brown here, we have another Brown here, and we have another Brown here. So right off the bat, we have 3 Browns with the same last name in this table. So we couldn't use the last name field as a primary key. Can we use the first name field as a primary key? Again, no, for the same reason why we could not use a last name field as a primary key, right? Alright, so for this table, there is no field, there is no one field that can be used to uniquely identify each record in the table, right? So, as I have said before, this answer is perfect based on the scenario that is given here. I am just going to tweak it a bit just to show you the importance of primary key and how to go about doing it. If you get a question to attempt, or you're creating a database and the fields that you have do not clearly present you with a primary key, what you can do is actually add a primary key to that table, right? So you just add a separate field, give it a name, and call that field the primary key. So let me show you what I'm talking about. So for this table, the scenario that was given, it gave us these fields, not true, first name, last name, age, gender, and date of birth. However, as I have shown you earlier, none of these fields can be used to uniquely identify each record in the table, right? So what I'm going to do, I'm going to create another field, and I'm going to call the field ID number, and I'm going to use it as the primary key because the ID number field will only have unique values, not true? So let me show you what I'm talking about. So I could have another row that is called ID, or I could call it student ID, or I could call it stud ID, or I could call it ID number, but I'm going to call it student ID, right? Why am I inserting this student ID field? Because as I have shown you before in this table example, we could not find any of the fields, either the first name, the last name, the age, the gender, or the date of birth field that could be used to uniquely identify each record, right, in the table. So here's a record, John Brown. Here's another record, Trudy Pink. Here's another record, John Brown again. Here's another record, and here's another record. So as I have said before, this table has 1, 2, 3, 4, 5 records or 5 rows in it, and it has 1, 2, 3, 4, 5 columns or 5 fields, right? Alright, so let's go back to what I was talking about. So the student ID field that we're inserting into this table structure, we're inserting it because we have identified that the current table format as it is does not present us with a field that can be used to uniquely identify each record, right? So what we're going to do is just give it a name, and we're going to give it a data type. I am going to say, okay, I'm going to give it a data type as text, right? We could give it as number if we're going to give the student ID only number values, or we could give it text, right? I'm going to say, okay, for me personally, I am not going to have a student ID that is larger than 10 values, 10 characters, right? So I'm going to put 10 here, and I'm just going to give a description. Said, okay, this uniquely, oops, spelled it incorrectly, uniquely identifies each record in the table and is used as a primary key, right? Good. So it means then in the sample table that was given, I need to add another column, right? And I'm going to give it the same name as we have here, student ID, right? And what we're going to do now is create a a structure, a format, and we're going to just stick with it, right? Most time when you're creating tables in the real world or for questions, right, they will give you a format for the primary key or a format for how you should do the ID number. So what I'm going to say, okay, my ID number is going to start with the word STU and some numeric values after that. So I'm going to say, okay, STU 001, STU 002, STU 003, STU 004, STU 005. Now if you look at this, guys, all the data in this field are unique. So if I come to you and said, fetch me the data for John Brown, how do you know which John Brown I'm talking about? What you would probably do is fetch me all three John Brown data. You would fetch me the data for this John Brown. You would probably fetch me also the data for this John Brown, and you would probably also fetch me the data for this John Brown. Not true, because there's nothing that can uniquely identify which John Brown I'm talking about. Not true. However, if I now come to you and said, fetch me the data from the student table for the student with the ID number STU001, right off the bat, all you have to do is go into the student column, right, and look for the student with ID number STU001. And since that we use the student ID as primary key, it means that every single value that would be in this column here would be unique for each row. So there would be no two person with the ID STU001, right? So it means that if I tell you to fetch me the record with ID STU001, you will actually return the exact data that I want, right? Compared to if I say you're supposed to fetch me this the data with for John Brown, for argument's sake. Alright, cool. I hope you understand the concept of primary key and the importance of it. Now, as I have said earlier, the initial table structure that we have created was correct for the question that was given. I just add the student ID field to the table structure to show you the idea behind primary key, right? So for exam purposes, you create the table structure for the fields that are given in the question or the scenario. So you would not add any extra fields to it, right, unless stated otherwise. Alright, however, in real world situation, right, you always want to try to have a primary key in each table that you created. Hence why I edited this table to show you how you could go about creating a primary key and the idea behind a primary key. Let us look at another example, but before we attempt this example, let me say that a table schema and a table structure is talking about the same thing, right? Cool. So this example states that we're supposed to create a table schema for a customer table with the following fields: customer ID, customer first name, customer last name, and customer telephone number. The customer ID will be a 7-digit number. Alright, so let's create the table structure for this scenario or this question. Now, the first thing that you're going to do is draw your table, right? And your table is going to have 4 columns, right? So you're going to have 1 column, 2 column, 3 column, 4 columns. Then you're going to label each column. The first column is going to call field name. The second column is going to be called data type. The third column is going to call field size, and the fourth and last column is going to be called description, right? Now, underneath the field name column, right, in the first row underneath it, what you're going to do is start to insert the fields that was given in the scenario, right? So the first field is customer ID, which is this one. So I'm just going to copy it, right, and paste it here. So the first field is customer ID. Now if you look here, guys, it says that the customer ID will be a 7-digit number. So right off the bat, we actually have an idea of what the data type for customer ID will be. Not true, it will be a number, a 7-digit. So we can either use a text data type and set the field size to 7, or we can use a numeric data type and set the field size to integer, right? I'm going to stick with the numeric data type. So I'm going to say okay, numeric, and we know that for numeric we can also call it number, right? And for the field size it's going to be integer, right? And I'm just going to give it a description. It says that stores customer identification. Oops, I spelled it wrong. Identification. Cool. The next row we're going to put the next field name, which is customer first name, right? And we have option in how we name it. So rather than call it customer first name, I'm going to call it customer underscore first underscore name, just to show you that you have option, right? And what do you think is a good data type for the customer first name field? Text, not true, alphanumeric. No. So I'm going to use the word alphanumeric just to show you that you don't have to use text, but what you can do is choose one and stick with it. Now, what do you think would be a good field size for the customer first name? The question did not give us a value per se, or give us an int of the largest value that will be stored in the first name, so we have to make an assumption. So I'm going to assume that okay, for this table I don't think a customer will have a first name larger than say 50 characters. So I'm going to put 50 here, and I'm just going to give it a description. Stores customer first name, and I'm going to do the same thing for the last name field, which is here, but I'm going to call it surname customer underscore surname, and again the data type is going to be alphanumeric or text, not true. So I'm going to stick with alphanumeric just to show you that you have option. What would be a good field size for the customer surname field? Again, the question did not give us an int of the largest value that might be stored in the customer surname field, so we have to make an assumption, and I am going to assume that nobody, none of the customer last name that will be entered into this table will be larger than say 70 characters. So I'm going to put 70 there, and I'm just going to give it a description. Stores the last name of customers, right? And I'm going to do telephone. Now for the telephone number field, right, which is this one here, telephone number, it is a interesting one, right? The word itself would want us to believe that the data type might be number. However, we have to be careful with fields like this one, and I will show you what I'm talking about. So the field name will be telephone number, or you can do something like this, telephone number with the number sign, right? Cool. Now the telephone field is an interesting one, right? And let me show you what I'm talking about. If in this table the values will be stored in the format xxx comma xxx comma xxxx, what this means is that you will have the area code such as 876, right, 876 dash, and you will have the first digit 891, then you'll have a dash, and let's say you have 5400, right? So this would be an example of an actual value for this format. If you're going to be storing your telephone numbers like this in this table, then you can't use a numeric data type. You would have to use an alphanumeric data type or text data type. However, if you're going to be storing your telephone numbers like 876, 891, 54, 00, then if you're going to be storing it like this, then you could use a numeric data type. However, if you're going to be storing it like this in this format, then you can't use a numeric data type. So let's assume that we're going to be storing it like this one, right? So it means then that the data type would be text or alphanumeric. It's just to show you an example. Alphanumeric. Now based on the format here, the largest value will be, let me show you, 1 2 3 4 5, 6, 7, 8, 9, 10, 11, 12. So the largest possible value for the telephone number field will have 12 characters. So I'm going to say okay, the field size is 15, and I'm going to give it a description like stores customers telephone number in the format area code, first 3 digit, last 4 digits. Right, so this is an example of the table structure or table schema for this question here. Now let us look at the final example. So in this example, what we're given is a table. So we're given this table here, right, and we're asked to create a suitable table structure for the table shown below. So we're given this table, and then we're asked to create a table structure that is suitable for this table, right? So again, what you would want to do is draw your table 4 columns, 1, 2, 3, 4 columns, right? And you will then name each column field name, data type, field size, and description. Right, now the first field name will be store num, which is this one here. Right, so we're going to copy it and we're going to paste it right here. Based on the data that is being stored in store num, what do you think the data type is? So look, you have Bertha, you have Dolly, you have Gustav, you have Anna, and you have Kyle. Those are text values, not true? Good. So it means that the data type would be text, right? And based on what I'm seeing here, based on the values, I don't see a storm name with a character set larger than 20. Let me see. The largest one is Bertha, which is 1, 2, 3, 4, 5, 6 character. But I'm going to say okay, 20 just to be sure, right? And I'm just going to give it a description to say stores the name of Hurricane. Right, the next field name will be origin, which is this one here. So under field name in the table structure here, we're going to type origin, and the data type is going to be text, and the field size, based on what I'm seeing here, the largest one would be Windward Island. So I'm going to count the number of characters in it. Right, so Windward Islands 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right, and I'm going to just add some extra characters to it to be sure. So 16, and I'm going to double it. So I'm going to say okay, 32. Right, the next field name will be date of origin, which is this one here. So I'm going to type it here, date of origin. Now, based on the data or values being stored in the date of origin column or field, what do you think would be a very good data type or field type? Good. If you said date, you would be correct. So a perfect data type or field type for the date of origin field is date. Right, and if you remember, for the date field or date type, you do not put any field size. You can either put the little dash or you leave it blank. Right, and for the description, I'm just going to give it a description. It says date of hurricane origin. Right, the next field name will be category. So under field name here, I'm going to type category. What do you think is a very good data type for this field or column? Number, not true, based on the values being stored in it. Right, 3, 2, 4, 2, 2, those are number, not true, numeric values. So it means for the data type here, I'm going to put numeric. Alright, numeric, and if you remember, we can also use number. Right, and what type of numbers? Integer, not true. So it means that in the field size, we're going to put integer. Right, and for the description, you would just type a description. So I'm just going to say okay, category of each hurricane, or any description that describes what the field is about. And the last field would be this one, major hurricane. So I'm going to type it, major hurricane, right? Now, what do you think would be a very good data type for the major hurricane field? Think about it. Now, if you said the logical slash boolean data type, you would be correct, because you should remember that the logical slash boolean data types are used on fields that are storing one of two possible values, so either yes or no, true or false, or a tick in a checkbox. Just remember that. And if you look at the hurricane, the major hurricane field, which is here, and the type of data being stored in it, yes, no, yes, no, no, you realize that it is one of two possible values, not true. So it means then that the logical slash boolean data type would be perfect. Not saying that you couldn't use the text data type, with a field size of 3. That could work as well, but the best one would be the logical slash boolean. As a matter of fact, for Microsoft Access, the logical slash boolean data type is called yes slash no, and I'm going to use it here. So yes slash no, right? And for the field size, you leave it blank, or you can put the little dash. So I'm going to leave it blank, right? And for the description, based on what I'm seeing here, I'm going to say okay, store whether the hurricane was a major one or not. And this is an example table structure for this table here, right? So you see, it's not very hard once we understand the concepts, right? So that is it for now. See you in future videos. Bye.